with it. So if you were struggling with this stuff a little bit, give me a week. Give me a week. Let's try and figure it out. You had hopefully some time away from doing work, and so just give me a week. See if we can get you caught up. You would probably be pretty amazed what you actually do recall. And then if you have some gaps in it, hopefully we can fill some gaps. Deal? So we have this worksheet 7.8, yes? All right, so let's take a quick look at number 1. We have x plus 2, x minus 2. And then number 2, same idea. We have x plus 4, x minus 4. And then number 3, 3x plus 1, and 3x minus 1. And number 4, 2x plus 5, 2x minus 5. Okay, so do you all kind of recognize that each problem, you have kind of the exact same things, but what's different between, what's the difference that's taking place? Yeah, I have a plus and I have a minus. I have a plus, I have a minus. I have a plus, I have a minus. I have a plus and a minus. Does everything else seem to be the same other than the plus minus? Does that make sense? So if you came across this, yes, you can go through. I'm going to only work one of them fully out. So I'm going to go x times x, that's x squared, minus 2x, then multiply this, plus 2x, and then minus 4. What looks like might happen on this problem? What's going to happen with these middle terms? Yeah, they cancel each other out. All right. So that didn't just happen by accident. These are actually called conjugate binomial pairs. Right? Conjugate. What are we in Spanish or something? Or not conjugate verbs? No. So conjugate math just means you have opposite sign. Everything else is the same, just opposite sign. So take a look at this. Notice the middle's canceled out up here. Agree? Everyone feel comfortable with that terminology? Okay, so my answer comes out to x squared minus 4. So I get the x squared by going x times x, and I get the negative 4 by going positive 2 times negative 2. So with that little inkling of knowledge, does anyone want to give me a shot at what number 2's answer would be? Opposite signs, right? So x times x is x to the second. Positive 4 times negative 4. Negative 16. Okay? If I multiplied the rest of it out, I'd get a minus 4x and a plus 4x. So there's no reason to. So here, 3x times 3x, that's 9x squared. 1 times negative 1 is negative 1. That's it. Anyone want to be brave enough to tell me the last one? 2 times 2, which is?
2x squared.
2 times 2 is?
Oh, 4. So 4x squared.
4x squared. And the rest?
Negative 25.
Perfect. That's it. Good job. Okay, so notice there is somewhat of a pattern with this. Okay? These are called the difference of two squares. Now, they have on the side, they have 1 squared. 1 squared is this. 2 squared is this. 3 squared is this. 4 squared is this. 5 squared. 6 squared. 7 squared. 8 squared. 9 squared. 10 squared. 11 squared. 12 squared. So those are perfect squares. Okay, so in that rectangle box on the right side, 1 times 1, or 1 squared is 1. 2 squared, which is 2 times 2 is 4. So on and so forth. Okay, so, I mean, if you don't know the perfect squares, it's okay. I mean, you could figure out what a perfect square is by just taking the number times itself and saying, oh, if I multiply two identical numbers together, my answer will be a perfect square. Okay? So it asks on number 5, what did we notice about 1 through 4? Does everyone realize that it's just the very first times the very last with the negative sign? Does that make sense? The very first times the very last with the negative sign, the very first, very last with the negative sign, very first, very last, negative sign. See a pattern? So difference of two squares. I have two perfect squares. A perfect square is a number that has two identical numbers multiplied together to get to it. So 9 is a perfect square because 3 times 3 is 9. Okay? So don't worry too much about 4 and 5, but let's take a look at 7, 8. Will you guys give me a shot at 7, 8, 9, and 10? They're the exact same, done the exact same way. See if you can figure out how they might factor out. Okay? We're not multiplying. See if you can figure out how to factor them out. Just a quick explore. See if you can see it. Yeah, so this is like the answer, right? Yeah, so you're filling out the binomials. So notice I have all these parentheses. Agree? So if you're stuck, let's try the first one. Do you feel comfortable x and x goes there? Does that make sense? It's not done, but let's go to the next one. X and x goes there and there. It's not done. We'll go on to the next one. Number 9, what goes in the very first spot? What do you think? X and x I agree with. Is there a number that goes along with it? Is there a number that I can multiply? 5? Yeah. So 5x and 5x. And these aren't done. What about the last one? What do you think? 2x and 2x? Okay. Now, let's go back a screen. What did we notice? What are all the green highlights we have? Opposite signs? Agree? Opposite signs. Everyone okay with that? So plus, minus, plus, minus, plus, minus, plus, minus. Agree? All right. What two numbers multiply together to give me 49? 7 and 7. Done. What about 81? 9 and 9. What about 64? 8 and 8. What about 9? 3 and 3. Friends, we just factored those out that quickly. Okay, so the things to note. The reason they call this difference of two squares is the very first thing is a perfect square because if I take a number and I raise it to an even number, that means it's a perfect square exponent. Okay? So x times x is x squared. That means x squared is a perfect square because x times x, two things by itself, multiply together. 4 times perfect square because it's on our list. Notice we have alternating signs, plus, minus, but they're the exact same binomials all the way through, except for the plus or the minus. Now, I could have a minus there and a plus there, minus there, plus there, minus there, plus there, minus there, plus there. That's also fine. It's going to be the same answer regardless. Yeah. I'm almost done. Can you give me a minute? Huh? Oh. An expression is called difference of two squares. So in that little blank that's above these, they want you to put in difference of two squares. Okay? Okay, so can we take a look at the back? Can we go to number 17? I'm almost done. Can you hold on? Is that cool? All right. So with what I just talked to you all about, do you feel number 17 is the difference of two squares? There's 3, so it's not 2 squares. It's 3, right? So this is 3 different parts. This is a trinomial. Okay? Before I had only 2 things. So if I had this one, let me just show you. This is not part of the problem, just so we can visualize it. If I had this, That's the difference of two squares, right? Because I have two terms. I have this term and I have this term. But this one has three terms. Okay, so critical thinking time, because all of these will be done the exact same way, I think. I'm going to do two sets of parentheses. Is this a perfect square? Meaning, are there two identical things I can multiply together to get 16x squared? Yeah, what times what? 4x and 4x? Do you feel okay about the first part? Okay, now, going back to what we were doing with factoring. In order for that very last number to be a positive number, my signs have to be identical. So they're either both positive or they're both negative. Looking at what we have up there, what would your guess be? Both positive or both negative? If they're both positive, the 40 would be a positive 40. Okay, so this right here is going to indicate they're both this sign. Hey friends, is 25 a perfect square? And what times what gives you 25? Done. Hey, does this one have alternating signs? Is 4x minus 5 and 4x minus 5 alternating signs? No. Okay. Go ahead. Crystal, go ahead. 18. Take a look at 18. See if you can try it. It's done the exact same way. Think about it. See if you can figure this one out. See if you can figure that one out. It's done the exact same way. Real quick, is 121 a perfect square? And what times what gives me 121? 11s. I got the answer up there. Do you agree? So how did I do these two as quickly as I did? I didn't have to show much more work. The reason is the very first term is perfect square. The very last term is a perfect square. You just have to think about the signs. Yeah.
Wait, how does 11 times 11 equal 22?
It equals, oh, I love this. I love this. You agree 11 times 11 is 121, right?
Yeah.
Cool. Ready? Negative 11 times x, negative 11x. Negative 11 times x, negative 11x. Negative 11x combined with negative 11x, negative 22x. Right? So if I were to multiply here, this part, and then outside, sorry, my hands are bringing up. Genetics. Okay? So it just kind of works that way. Let's see if we have some others that might be that way. My goal is to see if we can get this done before we leave. Can we? All right, let's take a look at this one. Okay, so kind of the first thing that we need to look at is this and this, is the first and the last, are they perfect squares? Yeah, what times what gives me 9x squared? 3x and 3x? What gives me 25? 5 times 5. All the signs are positive, agree? Oops, I don't want the highlighter any longer, sorry about that. So, ready? 3x, 3x, agree? All the signs positive. 5 and 5, done. Okay, these can be quick if you can recognize it off the bat. Well, I'm going to try and squeeze number 20 over here. I just wanted to go back to reviewing this. So first off, those were quick. Is 6x squared a perfect square? No, 3x times 3x is not 6x squared, is it? What about is 10? Is that a perfect square? No. So this one we have to go back to our traditional factoring. Okay, this is where we're trying to pull back what we had done like 9-10 days ago. Okay, ready? I'm going to multiply here times here. And that's going to give me a negative 60. Agree? In order to multiply two numbers together to get a negative number, what do you know about the two signs? Negative times negative is positive. So one of each. One of each. Okay? So I know that 1 times 60 is 60. Is there any way that I could make 60 and 1 add up to 11? No. What about 2 and 30? Can I make 2 and 30 somehow combine together to give me 11? What about 3 and 10? Or, whoop, 3 and 20, excuse me. It's not going to work. What about 4 and 15? I think 4 and 15 is a winner. Okay? So I think if I had a 15x and a minus 4x, do you feel comfortable that if I combine those together, I get positive 11? Cool. You remember us doing this? So I have 6x squared minus 10. Remember the ends come down, and I'm going to squeeze this in the middle of the two. So plus 15x minus 4x. Agree? What do these first two numbers have in common? X. Is there a number that goes into both 6 and 15? 3. So if I factor a 3 and an x out of 6x squared, I'm left with 2x. If I factor a 3x out of 15, I'm left with a plus 5. Agree? What does the middle sign always do? Comes down. Very good. So that middle sign is going to come down. What do I have in common between 4 and 10? What's the number that go into both? 2. So a negative 2 is coming out. The signs are going to switch. If I factor 2 out of 4, I'm left with a 2, and there's x. If I factor 2 out of 10, what do I have left? 2 times what gives me 10? 5. Notice the signs changed. Agree? Sorry, I got an itch on my foot. I couldn't get it. Okay, if these are the same, they're the first parentheses. What's the second parenthesis? Very good. There's our answer. Yes, I have my shoe off. I got an itch. Must be something I caught in Arizona. Scorpion bit me or something. Came across a huge rattlesnake on the back of my parents' property when I was down in Arizona. He was a big old, he was ugly. I'll just say that I heard the same story about 12 times in 5 minutes. But he was excited to tell me about it each time. All right, let's try one more. Number 21. Number 21. So is this one of those difference of two squares ones? Or is it an old factoring one? Yeah, so I'm going to multiply negative 6 times 5 to get negative 30. In order to multiply two numbers together to get a negative, what do you know about the signs? There you go. And so is there any way that 1 and 30 would combine together to give me negative 7? What about 2 and 15? What about 3 and 5? 3 and 10? I'm glad you guys are paying attention. Is there any way 3 and 10 would combine for a negative 7? Yeah, I think a negative 10x and a positive 3x would add up to that negative 7. Agree? So that's going to squeeze in right there.
It doesn't matter if it's a positive 10x and a negative 3x, it's still good, right?
No, that would give you a plus 7x. So the order is important on that. So it doesn't matter what order I plug those in, as long as the sign goes with it. So I have 5x squared minus 6. I'm going to squeeze in between this. So minus 10x plus 3x. So what do I have in common between 5x squared and 10x? 2 doesn't go into 5 though. X, anything else? 5. So if I factor a 5x out of 5x squared, what do I have left? X, and x minus what? Giddy up, minus 2. Middle sign always does what? What do I have in common between 3x and 6? What do I have left? 2. There it goes. Those the same? This week they are. Done. And then number 22. X squared minus 3x minus 70. So I technically have a 1 out front. Multiply those together, so I get negative 70. I think most of you are getting this. If I multiply two numbers together and I get a negative answer, what do you know about the signs of the two numbers? One's positive, negative. So 1 and 70. Is there any way 1 and 70 are going to add up to negative 3? No. 2 and 35? 3 doesn't work. 4 doesn't work. 5 does. 5 and 12? Getting closer. 7 and what? Does 7 and 10 work? 7 and 10 works. Which one has to be negative? So I get negative 10x plus 7x. If I combine those together, that's going to give me negative 3. So bring the ends down. So I have x squared. And I have minus 70. And squeeze in the middle, this. Watch your signs. Make sure you bring your signs with you. Okay, what do I have in common between those two? That's going to be x minus 10. Middle sign comes down. What do I have in common here? So my answer, x minus 10, x plus 7. Cool. So friends, I want to give you the opportunity to get this finished before you leave. Finish worksheet. So it's mainly just the back, right? Get it done.